Okay, so let's take a look now on how to graph this sine curve. So notice in this sine curve you have an amplitude of 2, okay, and the b value is 1/2, and more importantly that b value tells you your period because you always do 2 pi divided by the absolute value of 1/2, so 2 pi divided by 1/2 is actually 4 pi. C is 0 or none because there's nothing in the parentheses there, so you could say none. And D, this is that plus 1, so you're going to be shifting up 1. Okay, so keep in mind if you were asked to do the domain and range, you would do D minus A, and D plus A would give you your range, and the domain for every single one of these is all real numbers. And what I start with is I adjust my key values. So now my key values have to occur from 0 to 4 pi. So then I just cut that in half for the third one, so that gives you 2 pi, half of that is pi. So this one's nice and easy because it's 1 pi, 2 pi, 3 pi, and 4 pi is your 5 key values. Since there's no horizontal shift, I can go ahead and just put those on my x-axis. So I'll say 0, pi, 2 pi, and 3 pi, and 4 pi. So those are my key values. And now I have to look at the D and the A to kind of say what I want to count my y-axis by. I'm just going to count one block equal to 1. So in other words, 3 blocks would be 3. I need to shift up 1. So I'm just going to shift my baseline. It's kind of shifting your x-axis up by 1. And then I know that a sine curve hits the baseline at the beginning, the middle, and the end. And a sine curve has a hump above and a hump below. And since there's no reflection, I have a hump above first. How high do I go? I'm going to go 2 above. So from that second key point, I go up 1, 2. And then here I go down 1, 2. And then I put in my sine curve here. And it's a nice smooth curve. Okay. Now if I was graphing this one here, you have to be a little bit cautious because notice that what I really wanted to do here was have this in parentheses. So adjust your paper so that that's in parentheses. And what I wanted to point out is that this b value is supposed to be factored out for you to be able to graph it. So there is one like this on your test where it'll ask you what the horizontal shift is. And what you need to realize is that the horizontal shift cannot be determined until you factor out that too. So like for example in this one up here, that was just like, there was no parentheses, but in this one I wanted there to be parentheses there to show you that this is mathematically equivalent to y equals -3 sine. And now if I factored out that 2, you'd be left with x, but inside the parentheses you'd be left with pi over 2. And the way that you could check that is if you distributed this, it would take you back to the original. The other way to think about it is that you're dividing. So if you pull out a 2 here, you do 2 divided by 2 is 1. Pi divided by 2 is, well, it's pi over 2. So just keep in mind that you cannot determine your horizontal shift or your phase shift until you factor out that b value if there's parentheses. So I wanted to make sure I showed you that one. Okay, now I'm going to graph it just like before. So my amplitude is 3, but because there's a negative there, I make myself a note that there is a reflection over the x-axis. My b value is 2, which is important because that tells me that my period is going to be pi. And let's see, my c value is to the left, pi over 2. And again, you cannot determine that c value until you factor out. So again, there's definitely one like that on your test, so keep your eyes peeled. You cannot determine that phase shift until you factor out that b value. And here there's no plus or minus, so this would be none, or you could write 0. Okay, so from here, I'm just going to move that just a touch. My period is pi. So that would mean that my normal key values would be from 0 to pi. Okay, so that means that halfway between there is a pi over 2. Halfway between that is pi over 4. So you're counting by pi over 4s. So 1 pi over 4, 2 pi over 4, which is a half. The next one would be 3 pi over 4, and then 4 pi over 4, which is pi. So those were my key values, but then what happened is I have to shift each of them to the left. So now what I need to do is I need to subtract pi over 2 from each one of those. So 0 minus pi over 2 is negative pi over 2. That's easy. Okay, and then I'm going to skip that one for a minute. Pi over 2 minus pi over 2 is 0, and a whole minus a half is just a half. So those were kind of the easy ones. So then you have to kind of make the decision. Is it easier for you just to kind of figure out what's halfway between there, or is it easier for you to subtract? So, you know, most of you could tell that between 0 and a half is a quarter. So between 0 and a negative half would be negative a quarter. So you could just say that you could do it that way. Or you could get a common denominator here. This is the same thing as 2 pi over 4. So you'd say 1 minus 2 is a negative 1. Okay, either way, you should end up with those as your new key values. And we're going to take those key values and put them on the graph. So now I would probably count every other one as a quarter. So let's see, if I did that, I'd have a negative pi over 4 there. And then maybe a negative pi over 2 there. Oh, can you see that sign? Let me scooch it over. So that's, again, those are negative. And so that means this would be a 0. And then this would be pi over 4. And then the next one would be pi over 2. Okay. And again, I counted every other block as a pi over 4 just so that it would fit. If I skipped 3 blocks, then I wouldn't have enough room for this. So you just have to adjust and make sure you label your x-axis so that I know what you're counting by. So then I'm going to take into account the D and the A to figure out what I want to count my y-axis by. Since that's a 0 and a 3, I could just count each block equal to 1. So I'm just going to say 3 blocks equals 3, so that's easy. And this is a sine curve, so my x-axis is my baseline, so beginning, middle, and end. This one had a reflection over the x, so I'm going to start low, and it was 3 below and 3 above. So here is my sine curve. Okay. Now, once you have that done, if you were asked to go and graph the reciprocal functions. So for example, if over here you were then asked to graph y equals 2 cosecant of 1/2 x plus 1, all you would do is you would first graph this black one. Now, when you graph that, if you're using a pencil, you would graph in the black one very, very, very lightly, because that black curve is not part of the graph. You just kind of use it as a guide. So you know that whenever sine is on the baseline, that means that its reciprocal, cosecant, is undefined. How do you say undefined in math? Well, it's going to be a vertical asymptote. So wherever you hit the baseline, you just drop in your vertical asymptotes. And then, since it's positive here, you're positive, and you give it a kiss at the top and the bottom. And since it's positive, you're going up. Here it's negative. It's below your baseline, so it's going down. And so you have that shape. And again, if you were graphing this, like if it said pick out, which one of these graphs, and it was multiple choice or something, and it said which of the following graphs is cosecant, 2 cosecant 1/2 x plus 1, I would kind of sketch in the sine curve first, but that black one is not part of the graph. Just want to make sure I emphasize that. Okay, and over here, kind of ran out of room, but again, if I was asked to turn this into a cosecant graph, so basically the exact same thing, except for with a cosecant, you would again always graph the sine or cosine graph first, lightly if you can, and a pencil or an opposite color perhaps. And then, so I have it there, but I have to kind of scooch over. And again, wherever you're on the baseline, we're just going to drop in vertical asymptotes. So we just drop in these vertical asymptotes here. And you give it a kiss at the top and the bottom. And where it's up, it's up. And where it's down, it's down. So here it was below, so you're going down. Here it was above, so you're going up. And that would be how you graph the cosecant graph on this one.